All right, so today we're going to talk about spheres. So that's our objective, is to understand spheres and their formulas. Okay, and this is lesson 12.4. It's funny how this is kind of a short chapter, but it is packed full of things. So, spheres are all around us, right? We have spheres in our bodies. Our eyeballs are pretty much spheres, okay? We have spheres out in PE, basketballs, baseballs, softballs, volleyballs, okay? Notice that I use two words to describe that particular sphere because we don't need to have that conversation. There's other things out there like jawbreakers are spheres, okay? You can get some, meatballs, very good, are spheres, kind of. Gumballs. Marbles. Tetherballs. Okay, back to sports. Okay. Well, they are spheres. All right, so we're going to launch right into the two formulas, do a practice, and then we'll be done. Shh. Grip, get a grip. So, theorem 12.9. Boba. Boba are spheres, yeah. The area of a sphere. Now, remember, when they speak of area in our geometry book, they are talking about the surface. So if you're referring to, let's say, a basketball, you're talking about the orange part, right? So you're talking about that outer part. The area of a sphere equals 4 pi times the square of the radius. So, hearing words like pi and radius makes you think of circles. So basically, all you do with a sphere is you have a circle, you draw a diameter, and you rotate that shape along its diameter so quickly, boom, 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 it will form a sphere, a three-dimensional sphere. Okay. So the formula for area, again, this is surface area. And notice that we don't have a lateral area and a total area. We just have an area because there is no lateral sides. There's no top and bottom. So area, surface area, is 4 pi r squared. So unfortunately, even with prisms, pyramids, cones, cylinders, we actually only have two major formulas to memorize for prisms, two major formulas to memorize for pyramids, and then those formulas pretty much just get adapted for our cylinders and cones. So we have 4 formulas there, and now we have 2 more we have to add to our list that we have to memorize. The other formula is going to be for volume. And it says the volume of a sphere equals 4/3 pi times, now let's be logical about this one. If we're talking about a volume, what are we going to do to the dimension? You have to cube it because it's the same dimension all directions. So it's times the cube of the radius. So here's how, actually just thinking about it, this formula is not that hard to pay attention to. The first one has a 4, a pi, and r squared, because that's just area. The next one has a 4/3 pi r cubed. So we do have this that might help you remember the formula a little bit. Okay, so it still has a 4, still has a pi, still has an r, but volume is cubed, and we also have to take a third of that 4. Okay, so that might be a way to think about it. Okay, so let's go ahead and practice. And this will be something similar that you'll see on your homework. So directions are going to say something like complete the table. For spheres. Now, I think you've done this on just about every shape, where they give you a piece, and then your job is to figure out all the other pieces. So this particular table has a D, has an R, has an A, and a V. And then we're going to give you 4 different sets of information. So what's the D stand for? It's the diameter. And the R, radius. And the A, surface area. And the V, okay. So the only one that didn't show up in any of the formulas was the D. So in problem 1, oops, come back. Problem 1, we're going to give you the diameter is 12. Problem 2, we're going to tell you the radius is 7. Problem 3, we're going to tell you the surface area is 12 pi. Problem 4, we're going to tell you that the volume is 32,000 thirds pi. Okay, so our job is to figure out for each one of these the missing piece. So let's go to, or missing pieces I should say. Number 1. Super simple. If they give you D, you can figure out R. If they give you R, you can figure out D. That's pretty easy to go that direction. So if the diameter is 12, what's the radius? So it's half the diameter, and we get half of 12, gives you 6. Area, pi r squared. 4, pi r squared. So we're going to get 4 pi 6 squared. So we get 4 times 36. Which gives us, what, 144 pi. Okay, that's easy. Got it. Volume. 4 thirds pi 6 cubed. Okay, anyone remember 6 cubed? Well, no, dude, don't tell me 6 times 6 times 6. I know that. That's just expanding. Okay. 216, I heard somebody mouth it over there. Good job, thank you, Brooke. Now, 3 goes into 216 because the digits add up to 9, and I knew 3 was going to go in because I knew 3 goes into 6, so that could have helped me out as well. So we go 3 goes into 21, 7 times evenly into 6 twice. So now I'm left with 4 times that, and I get 828. So I get 288 pi. I think I'm actually going to have to elongate the volume column so we can write a little bit more neatly. Okay, number 2. We have the radius is 7, so the diameter would be, so diameter is going to be twice the radius, and it's 14. Okay, now area, 4 pi radius squared. So that gives me 4 pi times 49. So that gives me 36, 16, and 3 is 19, so we get 196 pi. Okay. Bless you, volume, 4 thirds pi radius cubed. Anybody remember what 7 cubed is? 63, no. Does involve a 3. 343? Yeah, it's always easy to tell me the answer after I write it down. Unfortunately, 3 doesn't go into that one, so we just multiply straight across, and we're going to get 4 times 343, we get a 12, 16 and 1 is 17, 12 and 1 is 13. So we get 1,372 thirds pi. Okay, good. Next one. Now they get a little bit sneaky. They give us the area as 12 pi. We know that is 4 pi r squared. Okay. So what we're going to have to do is solve for r in this case. So divide both sides by 4 pi. I'm going to use symmetric property. I get r squared equals 3, take the square root, and I get the radius is square root of 3. Okay. What's the diameter? Yeah, it's 2 times the radius, which is 2 rad 3. And then last would be volume. So volume is 4/3 pi radius cubed. So radical 3 times radical 3 times radical 3. What do I get with that? What do I get? I get 3 radical 3. The 3's cancel, and I'm left with 4 radical 3 pi. Now there's kind of two schools of thought on how to write that. Some people feel a little nervous with putting a pi after a radical sign. If you extend your radical symbol, is that pi underneath it or not? So some people write it 4 pi rad 3. Some people write it 4 rad 3 pi. So it kind of is up to you. If you're a sloppy writer, I'd put the pi after the 4 and before the radical. Okay, so 4/3 pi, or 4 radical pi. And then last one, let's go with this guy. Oh, they give us volume. And that equals 4/3 pi r cubed. So what I'm going to do is kind of a double thing. I'm going to multiply both sides by the reciprocal of 4/3, and I'm going to divide by pi at the same time. So technically what I'm going to multiply by is going to be, let's see if I can squish it in, I'll make them darker, 3/4 pi. So 3/4 pi. The 3's cancel, the pi's cancel, and now I divide 4 into 32,000. 4 goes into 32 8 times. Here, I'm going to put r cubed over here. R cubed. 4 goes into 32 8 times, and there's 3 zeros. So now I'm going to take, not the square root, but the cube root. So now my job is to come up with perfect cubes of 8,000. Well, that's actually really simple. 8 is a perfect cube. 1,000 is a perfect cube. Serves you well to memorize your perfect cubes from 1 cubed to 10 cubed. What's the cube root of 8? What's the cube root of 1,000? Multiply those together and we get the radius of 20. What's the diameter? Yeah, I'm not even going to show that one this time. All right, now we get to do the fun one. 4 pi 20 squared. All right, well, 2 squared is 4. 10 squared is 100. Together, that gives me 400. So this is 4 pi 400, which gives me a grand total of 1,600 pi. Okay, and that's what you guys are going to be working on, part of your homework.